Have you ever looked up at the night sky and wondered what lies beyond? For centuries we thought the universe followed simple, visible rules. But science has revealed a reality far stranger than we ever imagined. Today, we're on the brink of discoveries that challenge everything we know about space, time, and connection. This story begins with a puzzle that baffled the greatest minds and ends with a Nobel Prize that changed our understanding of reality. We'll journey into the quantum realm, a place where the rules of everyday life simply don't apply. Here, particles can be in many places at once, and connections exist that defy common sense. This is not just a story for scientists, but for anyone who's ever questioned what is real. So, take a deep breath. Let's begin our journey into the heart of the universe's greatest mystery. Prepare to leave behind the world you think you know. What is quantum entanglement? Imagine two quantum coins flipped and sent to opposite ends of the world. When you check one and see heads, you instantly know the other is tails, no matter the distance. In reality, it's not coins, but particles like photons or electrons that become entangled. Their properties are perfectly linked. Measure one, and you instantly know the state of the other. This connection is immediate, defying the usual rules of cause and effect. Entanglement suggests a direct link between particles outside the limits of space and time. Before measurement, both particles exist in a haze of possibilities. The moment you observe one, both instantly settle into definite opposite states. It's not prearranged. The act of measurement itself creates the outcome for both. This is the heart of quantum entanglement, a mystery that challenges our deepest intuitions. It's a phenomenon that even Einstein called spooky action at a distance. Yet it's real, and it's reshaping our understanding of the universe. Welcome to the world where reality is stranger than fiction. Not everyone accepted this bizarre idea, especially Albert Einstein. Einstein, with Podolsky and Rosen, argued in 1935 that quantum mechanics must be incomplete. They believed in local realism. Objects have definite properties, and nothing can influence something else faster than light. Entanglement seemed to break both rules, suggesting properties aren't real until measured and that influences can be instantaneous. Einstein called it spooky action at a distance and proposed hidden variables, secret instructions that determined outcomes from the start. He compared it to sending gloves in boxes, open one and you know the other, but there's no magic. The debate between Einstein and quantum pioneers like Niels Bohr raged for decades. Was the universe predictable and local, or fundamentally strange and interconnected? For years it seemed like a philosophical argument with no way to test it. The question of whether reality is local or non-local remained one of science's greatest mysteries, but eventually experiments would provide the answer. The stage was set for a revolution in physics. In the 1960s, physicist John Bell devised a test to settle the debate between Einstein's local realism and quantum mechanics. Bell's theorem provided a way to experimentally distinguish between the two views. John Clauser was the first to take up the challenge, building an experiment to test entangled photons. His results supported quantum mechanics. Entanglement was real, not just a mathematical oddity. Alain Aspect refined the experiment in the 1980s, closing loopholes and confirming Clauser's findings. The evidence grew stronger. The universe truly operates in a non-local, spooky way. Anton Zeilinger and his team took it further, entangling particles over vast distances, even between islands and satellites. They closed nearly every loophole, proving beyond doubt that quantum entanglement is a fundamental feature of reality. Their collective work transformed entanglement from a philosophical puzzle into an observed fact. In 2022, Clauser, Aspect and Zeilinger were awarded the Nobel Prize for this achievement. The universe, it turns out, is as strange as quantum theory predicted. The mystery was solved not by philosophy but by experiment. But the story of entanglement has a forgotten chapter. Decades before the Nobel laureates, Chien-Shiung Wu provided the first experimental evidence for entanglement. In 1949, Wu and her student created entangled photons and proved their polarizations were perfectly linked. This was the first laboratory proof of spooky action between separated particles. Her work laid the foundation for all later experiments, yet her name is often left out of the story. Even Nobel winner Anton Zeilinger acknowledged her pioneering contribution. Wu's experiment was the first glimpse into the strange reality of quantum entanglement. Chien-Shiung Wu's brilliance shone despite immense adversity. Born in China, she came to the US in 1936, quickly becoming a leading experimental physicist. She contributed to the Manhattan Project and made discoveries that changed physics forever. In 1956, Wu proved that the universe isn't perfectly symmetrical, overturning a fundamental law. Yet, when the Nobel Prize was awarded for this discovery, Wu was left out. Despite discrimination, she became the first female president of the American Physical Society and had an asteroid named after her. Wu's life was one of sacrifice, dedication, and scientific rigor. She never saw her family again after leaving China, but her impact endures. Her story is one of resilience and the fight for recognition in a world slow to give it. Wu's legacy is a testament to the power of perseverance. Why does entanglement matter? For years it was a curiosity, now it's fueling a technological revolution. Quantum computers use entangled qubits to solve problems impossible for classical computers. This could transform medicine, materials, and artificial intelligence. Entanglement also enables quantum cryptography, communication that's fundamentally unhackable. Any attempt to intercept an entangled key is instantly detected. These advances promise secure transactions and data protection in a connected world. Beyond technology, entanglement deepens our understanding of reality. Some physicists believe space-time itself may be woven from quantum entanglement. What began as a spooky oddity is now a pillar of modern physics and a tool for exploring the universe's deepest secrets. The future is filled with possibilities we're only beginning to imagine. We've journeyed from Einstein's doubts to experiments that proved him wrong, and from forgotten pioneers to a technological revolution. The universe we thought we knew is giving way to a vision of deep, fundamental connection. The same laws that link particles may hint at a unity underlying all existence. We are not just observers, but part of the universe's entangled web. Every atom in our bodies follows these quantum rules. Our quest to understand the cosmos is a quest to understand ourselves. Scientists continue to push boundaries, exploring the implications of this new reality. The legacy of Wu, Clauser, Aspect and Zeilinger is not just answers, but new questions. The universe is strange, beautiful and always surprising. The story of quantum entanglement is just one chapter in our ongoing adventure. Thank you for joining us on this journey through the mysteries of modern science.